The next one we want to find here, they give us a function f of s to be 2x plus 4 and another function g of s to be s squared minus 2. Now we want to find, they said number one, compute g of f. That is g compose f, g LCs f. Now once again I will show you that our question are authentic. They're coming from a source. This is it. Number 2a, f of s equals that, f of g of s equals that, and then compute g of f, and at what point we do that later. So just showing you that it is a question that is pertinent to our UI student, and for somebody out there that you want to be so good in math, these are questions to check yourself out, check your levels if you understand this thing so well. And if you don't understand it well, check the video. You cannot go through this video and not understand it. That's one thing I can assure you. Now let me continue. Now the next thing we want to do is that we want to get g compose f. What does that mean? We have said it before in one of our videos. Go check our page, Emancipator channel. You see there. Now I've said it before that g compose is just the same as what g housing f of s. Are you getting what I'm saying? That's what g composition is all about. If I compose you, then I will house you. That is, your house composes you. Let me use that word. Your street composes your house, because your house is within your street. Your state compose your street, compose your local government, not just you housing. Are you guys what I'm saying? It's everything within you will be within that range. And what do? Now g compose f of s, and what's f of s? Write it there in that bracket. So that will be g into, initially it was g into bracket f of s, but our f of s is what? 2s plus 4. So put it instead of leaving the f of s there. So the next thing is this. We know the definition they gave for x, for g of x. They said g of s is actually x squared minus 2. But we want to find g of 2x plus 4. Just what we do in polynomial substitution. Anywhere you find x here, right here, anywhere you find x here, put 2x plus 4 there. So instead of s squared, that will be 2x plus 4 all squared minus 2. Simplifying 2x plus 4 all squared, that's this one squared. Let me give you a trick. Square the first term, that's 4x squared. Now, square the second term, that is plus 16. Now, the first times the second, 2x times 4, 8x, double it, 16x. Again, I said square the first term, 2x squared, that's 4x. The last term, 4 squared, 16. It is positive, so you don't need to bother yourself about anything. Now, the first term times second term, that's 2x times 4, 8x, double it, 16x. So that's how we get this one here. That's a short trick to expansion. Now, then you subtract 2 from it. Then somebody is saying that is what? 4x, don't mind me, it will still be in the next slide. Just try and do it here. 4x squared plus 16x, then 16 minus 4 plus 14. That is our g compose f. So the answer is what we write here. Don't mind me. We write a beautiful answer right here. That's it. Now the next thing in the second question, if you can go back to the question. For those of you that don't have it, you can reverse it, or let me show you so that it will not be as though I'm stressing my audience. Now let me say this is the question. The second part is what? At what value of x will f compose g be equal to g compose f? Now we already know g compose f, right? We already know this side. So what do we care about? Let's just go for this. F compose g. That will be f we house g of s. And what is g of s? S squared minus 2. But you don't forget that f of s itself is 2x plus 4. That is what our f of s is, 2s plus 4. Now, if f of s is 2s plus 4, you want to find f of x squared minus 2. And when you find s, put s squared minus 2. And if you open this bracket, so that will be 2 into bracket s squared minus 2, then plus 4. If you open this bracket, you get 2x squared, 2 times minus 2, that's minus 4 plus 4. So at the end of the day, f compose g of s is actually what? That is 2x squared. So the next thing we want to do real quick is just what? This forward value of s is this side equals this side. Now, we then equate We know what we got from G for F compose. This is 2s squared. That's the value for F compose G. Now what's the value? What do we get for G compose X? The first question we solve, that's 4s squared plus 16x plus 14. Now for what value of S will this thing be correct? That's the question. And what do we do? Bring this one here, then set it equal to 0, solve it quadratic wise. So that will be 4s squared, collecting like scheme, 4s squared minus 2s squared, that is 2x squared plus 16s plus 14. We solve it quadratic wise to get the value of x at that point. Now let me continue my explanation here. So what do we want to do? We want to solve this quadratic expression now. We want to solve the quadratic, by factorization. We want to solve it, the quadratic expression by factorization. So how do we do that? That is to bring everything here. The first thing is that we notice that 2 is common to everything. What is factorization? Factorization is gotten from the word factors. You see a common factor, then you bring it out. That is factorization. So someone can say, do we do double factorization here? Yes. We factorize twice. Do you understand? Now, so we notice that 2 is common to the term naturally. So we brought out the 2. Now someone will say, if I don't bring out the 2, will I still get the same thing? Yes. Only that you get a multiple of what we get. And at the end of the day, multiple in terms of x, with a coefficient of x. And when you simplify it, you still get the same thing. So either you factorize at the early stage, bringing out the common numbers, because not all quadratic equation will be number common like this. Like we have a common number, like a common factor number wise. Let me use that word, like just without going through the factorization procedure, get the product, get the sum and all of that. Is it every quadratic equation that will be like this? No. But there are some that are like this. So the best thing you're supposed to do is just to bring out the common number so that you already reduce that into its least form. Then you can continue playing around it. So this one will reduce it to its least form by bringing out the 2. Then the next thing, we need to factorize this part. So factorizing it, if you know, by quadratic, take the product of these two. That's 7x squared. Factors of 7, that is 1 and 7. So you add the 2, you get 8. By addition, you get the sum. By multiplication, you get the product. So that will be s squared, x squared plus 1s, which is the same as s, plus 7s plus 7 plus 7. Don't mind me. So when you bring this in bracket, bring this again in bracket, you have x into bracket what? X plus 1. And plus 7 again, you have x plus 1. So that's how we get x plus 1, x plus 7. Do you understand? Continue the procedure. That is x plus 1, x plus 7. Now, t equal to 0 is not actually going to be something, it's not going to make any sense. So these are our factors, right? We have to, so what do? Once you say 3 things equal to 0, the product of 3 things equal to 0, there is a rule. If the product of 3 things equal to 0, either of them will be equal to 0. Either of them, like either one or the other will be equal to 0. That is, if you pick 3 number, you multiply it and you get 0. There is 100% assurance that I will have that for you to get 0, then one of them must be 0. Only that I may not know which one will be 0. Right? I may not know, because there's no 3 number you pick to multiply, you get 0, and any of them is not 0. It's never possible. It's never possible. We are not talking about addition here. We are talking about multiplication. So for this statement to be correct here, then either of them will be 0. That's why we now say that 2 equal to 0, or x plus 1 equal to 0, or x plus 7 equals to 0. And 2 equal to 0, this is mathematically wrong. That's a fallacy, actually. It can never be possible. 2 can never be 0. There are 2 different elements in the real numbers, so it will never be possible. So now for x plus 1 equal to 0, if x plus 1 equal to 0, that can be possible. Then in that situation, bring this one here to know the value of x at that point. So that will be x equals minus 1. And if x plus 7 equal to 0, then bring the 7 to the other side. That's minus 7. So that is f compose g and g compose f. They are equal at the point where s equals minus 1 or minus 7. That is only the point. They are equal. At every other point in x, they are not equal.